Welcome back, welcome back, welcome back. I'm Lisa Blackburn, and this is my YouTube channel where I talk about anything I want to, science and math. And today we're in chemistry class talking about measurements in chemistry. See, that's funny, isn't it? Okay, so we're going to review, because the part one video cut off here, the rules for how to know. The real point of this is, how do you know where to round? Like, and our example was that if you measured the mass of something to be 2 grams and the volume of it to be 3 milliliters, and you're calculating the density, and density is mass over volume, and so you do 2 divided by 3, your calculator would say 666666667. How do you know where to round? Well, we have rules for it. Now, so the first rules has to do with addition and subtraction, and with it, you round your answer to the same number of decimal places and as the number with the least decimal places. Oh, and my board's messed up. I have to think real hard how to write. Oh, I did that so good. Okay, so like if I was adding 3 and 0.25, the answer would be 3. 3 plus 0.25 is 3. Now that seems crazy, doesn't it? But it's because you can only report your answer with adding and subtracting to the decimal places that is the least. And just 3 only goes to the ones. 0.25 goes to the hundredths. So 3 plus 0.25 is 3.25. But now I have to round it to the one with the least places, and 2 leaves 3 alone. So the answer is 3. Everybody follow along? It's a little awkward, but you know, that's really fun, isn't it? Because in school, y'all are smart. It gets boring because you learn the same stuff over and over again. And in this class, you're going to learn stuff you have never learned before. So, you know, it's going to be more interesting. Okay, and now, so it's a different rule with multiplying and dividing. We're back to our density formula. Here, you do the same thing, but you have to know, you look at the number and see how many significant figures it has. And significant figures are measured figures. And so there's a whole lot of rules to know what the significant figures are, which y'all seem to understand because you did get on your daily warm-up. But the same rule, this rule is very similar. You round your answer to the number that has the least number of significant figures. So all non-zero digits are significant. So 123.45 has how many? 123.45 has how many significant figures? 5, because all non-zero digits are significant. 102 has how many? 3, because zeros in the middle are significant. 0.002 has how many? 1, because zeros at the beginning, when there's a decimal, don't count. They're just placeholders. 21.3000 has how many? 6, right? 1, 2, 3, 4, 5, 6. Because zeros at the end after a decimal count. Zeros at the end of a number with no decimal are not significant. So 4,200 has how many? 2, because the ones at the end with no decimal don't count. All right? All right, and you got a worksheet on that. Now, I put the worksheet on Canvas, and I also put the key on Canvas. So I always do that because I feel like the best way to learn math is to do a problem, check your answer, do a problem, check your answer. So even when I teach like Algebra 1 or Algebra 2, I always assign for homework the problems that have the answers in the back of the book, because homework is not the test. The test is where you can show me you can do it without my help. For homework, you need to be able to have that immediate feedback to know that you got it right. So I always try to give you the answers so you can do a problem, check your answers. Now, what's to stop you from just copying down all the answers? You'll fail the test. There's no way to do this without practicing it. So if you don't practice it and you just copy down the answers, you're failing. You know, sorry about that, but you are. That's how you're going to learn it here, is by practicing problems. Any questions so far? All right, y'all are doing good. Okay, next. Dimensional analysis is changing between measurements. So mathematically, why this works is because if you multiply anything by 1, you don't change its value. 6 times 1 is 6, right? Anything divided by itself is 1. 3 divided by 3 is 1, correct? So I can have two things that are equal to each other that are written differently. 7 days in 1 week is the same thing. So if I divide 7 days by 1 week, mathematically, it's equivalent to 1. And I can multiply it by something and it doesn't change its value. This is a huge idea in this class. This is going to be our main math idea we're going to use throughout the class. So make sure, even if you don't understand it, that you can do it. Okay, eventually it'll start making more sense and you'll understand it more. All right, so the conversion factors are equal to 1. Example, 1 meter is 100 centimeters, 7 days is a week, 12 inches in a foot. How many seconds until break? We figured that out. And you just, I don't want to redo that problem, but I'll do this one. How many centimeters in 4 feet? Okay, so whenever you do one of these problems, you start with writing what you know. Now, I like to do little hand signals and stuff to help you remember what you're going to do. And I did a learning styles inventory, and I think I'm a tactile learner, but it helps everybody. So like when I teach geometry, I have things to help you remember the properties. Like if I do this, it's the reflective property because this is a mirror. Y'all had geometry yet? Do you know about the properties and the proofs? A little bit? Yep. Okay. And like this is, this is A equals B and B equals C. Anyway, I have these little hand signals. This is 1, 2. But anyway, so in this class, we always start with what we know. And how I remind you for this is I say, what do we start with? You start with what we, and you say no. Okay, so you ready to practice? We start with what we know. Very good. Because eventually we're going to do this real long problem. And it will have many, many steps to it. It will take like a half a piece of paper. And I will call on you to do it. And you're going to panic and you won't know what to do. And I'll say, first, start with what you, and you go, no. And then you remember. And then I'll say, and then you're going to, you'll go, train tracks. And I'll say, yeah. All right. So we have little signals to help you get through the problem. So if you play along, I promise it helps. All right. So we're going to do this, and what we know is 4 feet. So we start with what we know, which is 4 feet. And you write down what you know with units. Now, then I draw train tracks. Some people use parentheses, but I've done this for decades. We don't talk about how many. And I have seen students turn parentheses into sixes and then get it wrong because of their messy handwriting. And they do better with train tracks. So we're going to do train tracks. Okay, so first you write what you know, and then you take the units of what you know and you push it to the denominator. Now, I think it's more fun with sound effects. So I'm going to put feet down here in the denominator. Now I think, do I know a conversion factor that tells me how many centimeters are in 4 feet? No. But I do know how many inches are in a foot, right? Did y'all learn stop, kaput, 12 inches in a foot? That was a first grade curriculum. So there are 12 inches in 1 foot. 12 inches on 1 foot is the same thing. If I divide something by myself, it equals 1. Anything times 1 doesn't change its value. That's what I'm talking about. Okay, so now we keep going, and I push the inches to the denominator. More fun with sound effects. Okay, now I do know the relationship between inches and centimeter. 1 inch is 2.54 centimeters. Now you might not know that. You might have to look it up, but I know it. So, but if it's something like that, I'll give it to you, or I'll give it to you to write down on your cheat sheet. Okay, so now if you have the same thing in the numerator and denominator in math, what can you do to it? If you have the same thing in the numerator and denominator, like an X, what can you do to it? You can cancel it out. That is one of my favorite parts of math. And I know it's dumb, but there is just something very satisfying about marking out math. You feel like, haha, I get to mark you out, you math. I don't know why, I just love it. So anyway, we get to do that. There's a foot in the numerator and a foot in the denominator, so they mark out. An inch in the numerator, an inch in the denominator, they mark out. You multiply any number in the numerator, you divide any number in the denominator, but you can ignore ones because anything multiplied or divided by 1 is itself. Good? Okay, so somebody do it on their calculator, 4 times 12 times 2.54, and tell me what it is. Araceli, you have to have a scientific calculator for this class. So, and I recommend TI 84. Yes. What'd you get?
121.92.
121 point what?
92.
92. Now, if we were really going to go by significant figures, what should we round it to? How many significant figures should my answer have? Did I multiply and divide or add and subtract? Multiply and divide. How many significant figures does 4 feet have? 1. How many significant figures does 121.92 have? 5. How can I round that to just be one significant figure? 100. 100. That is a little hard to do, isn't it? To turn that beautiful sciencey looking number into 100. But that's the rules. So it gets easier though, okay? All right, now, international measurements. In science class, we use measurements that can be understood all over the world. What did I do with my thing here? Here it is. Try to make sure I'm writing the same thing again. Yep, understood. Oh, that's easier. Okay, so my son Nathan, the oldest, I got 3 boys in college. The oldest one is at Georgia Tech. He's getting his doctorate, his PhD in chemistry. And he watches videos from all over the world of people doing chemistry. A lot of them are from China and a lot of them are from India. And they are speaking Punjabi in the Indian one or Mandarin in the Chinese one. And he does not know Punjabi or Mandarin, but he can sit there and watch their videos and understand what they're doing because we use the same scientific language all over the world. We use the same exact elements on the periodic table, and we do math the same way. And that goes back to our standard, is that we are learning to obtain, evaluate, and communicate information. So one of the ways we do that is our standard of measurements that we use are the same, and the official one is Le Système International des Units. I'm sure I said that in perfect French, but we abbreviate that SI. I'm so glad we do. I'm not very good at French. I have been to France. And sometimes we use the metric system. They're slightly different, but they're pretty much the same. The metric system. So you need to know for your test coming up the base units, but I bet you already do. What is the length of the measurement of length in the metric system? Meters, right? Not yards and feet. We use meters. What's the symbol for meter? Do you know that?
M.
Lowercase m. Okay? Moving right along. Are we good? Can I scroll? Excellent. All right. Let me take something real quick. Make sure I ran off what I want here. Okay. All right. What is the unit of mass in metric? But the base unit, we're going to just say gram with no prefixes. And what's the symbol for gram? G. A lowercase g. And someone's right. Okay. What's the unit for time? This is good because it's the same as what we use in English. Second. The base unit is second. I was writing up, sorry about that. Now current, you might not know, it's ampere, but it's abbreviated amp, and you've heard of amps, right? Amps, maybe in a car stereo or something. So it is ampere, and the symbol is big A, okay, ampere. Temperature, in SI, it's Kelvin. Oh, it sounds almost like a guy's name or a girl. I know a girl named Kevin. So, but it's Kelvin, Kelvin. The symbol is a big K. And in metric, temperature is Celsius. So that's one of the places it's a little bit different, and the symbol is big C. Okay, volume actually has 2 different ones in SI. It is, what do you buy Coke in? Big Cokes, what is it? Liters, right? So volume is liters, which is a big L, or it's cubic meters. C-U-B. Cubic meters. And you need to memorize, it's on the test, that 1 cubic centimeter equals 1 milliliter. That's a test question right there. You just got to memorize it. So like in medicine, they'll use cubic centimeters. They'll say, get me 100 cc's. You might have seen that on a crime, some sort of drama where there's a hospital going on. Okay? And then in science class, we usually use milliliters. Okay? Not going too fast? All right. Energy is a unit you probably are not familiar with. It's joules, Joules. It sounds like a diamond, but it's spelled different. The symbol is big J. Pressure, there's a bunch of them, and we'll learn more of them when we do the gas laws toward the end of the semester. But a few of them are pascals. Another one is millimeters of mercury, mmHg. The H is capitalized. Or ATMs for atmospheres. So there's a bunch of them. All right. Feeling good about this? Okay, next. The reason why I like the metric system is it's easier to convert between. I like the English system because I think it's more convenient. If you ever watch the Great British Bake Off, the units they have, or they do the metric system in England, we do the English system here. But our teaspoons and cups and things are much more convenient for cooking. They are always trying to weigh things out in grams, and things can weigh different depending on the humidity in the air and stuff like that. It's just it's a less convenient unit. And a lot of people, because of that, who I know, who come from countries who use the metric system, they never measure anything when they cook because it's just not convenient. They don't have a convenient way to measure. So I think we should go. So my goal is to be queen of math and science in America. I don't want to be elected. I just want to be a dictator. And I would change it where we would only use the metric system in science and we'd use the English system day to day. Because when I grew up with the English system, but they introduced the metric system that we were going to go to, and it was the weird thing, and I could keep it straight. The English system was the normal thing, gallons of milk, feet for measurement, pound for weight, and metric was the weird one, meters and liters and Celsius degrees, okay? But you guys have grown up with both systems. You are just as familiar with liters of Coke as gallons of milk. And what has happened is, just as a teacher observing, you are the worst at measurements of any group I've ever taught. You don't understand, you don't have a good understanding where you have the ability to estimate. Oh, that's about, and y'all don't even know how to tell time with an analog clock. So as queen of math and science, I'm going to switch that up. There's other things I'm going to change too. Like I'm going to change what the properties are called in math. Distributive makes sense. Communicative, no it doesn't. We need a new name for that one. They need to sound like what they are so they're, actually useful. So I have big plans. So I guess I have to wait till one of y'all become president and I can be appointed head of education and I'll straighten it all out. But maybe I need to be head of commerce because I really want to change it for everything, not just education. Okay, yeah, big goals, big goals. Okay, so this is what makes it easier for science class, is it's easy to convert between measurements. You don't have to do the dimensional analysis. You can just move your decimal point, okay? So this is how you can remember how it works, is this little sentence, King Henry's daughter bakes delicious chocolate muffins. So there's the chocolate muffins and there's a picture of King Henry's daughter in a minute. And what it is that these prefixes go with the basic units and it tells you the value. And what the prefixes are kilo, hecto, deca, basic, deci, centi, milli. So I'm going to write them kind of this way. So this one is, I think I'll just write over here. Kilo, hecto, deca, basic, we'll put a little print, deci, centi, milli. So that's what they stand for. Okay, so this is how it works. We're going to change 4,800 kilometers to millimeters. So first you write down what you got. 4,800. And its decimal point, if it had one, would be right there. I'm going to go from kilo to milli. Kilo to milli. I'm going all the way from K to M, and I count how many frog hops that is. So the princess is drawn wrong. My son Josh drew her. He should have drawn Tiana from Princess and the Frog, because she's the princess and the decimal point is the frog. And the frog is going to hop to its proper place. And it's 6 places this way. 1, 2, 3, 4, 5, 6. Everybody see how I counted the 6 frog hops? So now I'm going to take my frog, and he's going to hop 6 places over. 1, 2, 3, 4, 5, 6. And then I draw the zeros there. I'm going to augment zeros. And so the answer is 1, 2, 3, 4, 5, 6, 7, 8, 9. 4,800,000,000 milliliters, right? Because those are 800 million. Yep. Okay? You see how I did it? Let's do another one. We're going to change liters to centiliters. So I'm going to get a different color on my drawing. No, I'm not. My board is not calibrated, so it doesn't let me click on it. Let me do it over here. Let's see if I can get another color under draw. For that, we'll go with red. All right. Okay, so this time I'm going to change liters to centiliters. So liters is a basic unit. So basic is grams, liters, meters, seconds, amperes, joules. Whatever your basic unit is, we just learned, that's what we're moving from. So we're going from liters to centiliters. So this is my basic to C. 1, 2 frog hops. Does that make sense? So my decimal point is going to go, I got 6. The decimal's right here, and I'm going 1, 2 over. So the answer is 600 centiliters. Feeling good about this? Okay, let's go on up. This time we're going to change milliliters to decaliters. Big D is deca, little d is deci, and how you can remember that is all the E's go together. Deci, centi, milli. Do you see how those all end in E? Okay, so now this time I'm going from milli, let's change the color again. I'm going to do it over here. Because my board won't let me. I need to look up how to calibrate this board or send a ticket or something. But right now, it just is not working.
I'll just send you the packet.
What?
I'll just send you the instruction.
That'll work. Just tell me how. I'll do it myself. Okay, so this time I'm starting at milli. Go down there. And I am moving to deca. 1, 2, 3, 4 places that way. Okay, so now here's my decimal. I guess I'll write it here. 679,000. Here's my decimal point. 1, 2, 3, 4. The answer is 67.9 decagrams. Okay? Think you can do that? That's easy, isn't it? You just move it as many places and in the same direction. Okay, density. Yay, we're almost done. So I already told you density is mass over volume. So we're learning how to do math, so we need some math problems to do, so why not density? Density is a physical property. You have physical properties, things like the element's color or its ability to conduct electricity. And then you have chemical properties, how it's going to interact with another chemical. Is it flammable? That would be a chemical property. But physical property, density is one of them, and it's mass divided by volume. So we're going to do a word problem. What makes a word problem hard is what? Is it the math or the words? It's the words. So what do we want to get rid of? The words. So how we do that is we annotate the problem. We write on it. So what is the density? What is a question word Density is what it's talking about. So density, I put a question mark on. That's my unknown. That's what I'm looking for. I hate it when I just get so excited about doing a problem that I jump in without looking at it, and I realize I solved for the wrong thing because I didn't read the problem correctly. I get too excited about my math problems. They're very fun. Okay, I love math because it's like a video game you can win, like actual money if you're good at it. Okay, what is the density of a piece of lead? Lead is a chemical that might be important, so I circled it. That has a mass, okay, of 114 grams. I'm going to write M on that for mass, and a volume of 10 milliliters. So I think to myself, is there a formula that relates mass, volume, and density? Yes, there is. Density is mass over volume. So this is how we do our problem. We list the knowns and unknowns. So I'm going to say density equals question mark, mass equals 114 grams, and volume equals 10 milliliters. So I did the first thing. Then you think, is there a formula? Yes, there is. Density equals mass divided by volume. And then you substitute the numbers in for the letters in the formula. And when I do this, I sing a song, okay? So when I was in 9th grade, I had a severe concussion. I had a horse growing up. It wasn't my horse, it was my friend Becca's horse. And I got run under the barn and had a super, super bad concussion. This was the dark ages of the 80s when I was a teenager. But nowadays, if you have as bad a concussion as I had, they send you home for a year and tell you not to think. But in these dark ages of the 80s, they didn't know much about concussions and concussion therapy and all that. And I don't think I even missed a day of school. And it was so hard to learn. I had always been in the gifted program. I had always made straight A's. And suddenly here I am in Algebra 1, Honors Algebra 1, and everybody else seems to understand and I don't. Well, it's because I had a horrible concussion. And so I had to make up all these ways to help me remember what to do. And one of the things I did was I made up songs that would tell me what to do next. And so the song I would sing at this point of an Algebra 1 problem is Substitute. It's by The Who. It's before my time and your time because it's like from the 60s. And it goes like this. Substitute. Now, you can do math without singing and dancing. I know it's hard to imagine, but you won't have as much fun. And it actually helps you remember the next thing. So this is where we sing Substitute. And we're going to put the numbers in. I saw double for like 3 months. It was terrible. Anyway, I'll tell you the whole story sometime. Okay, so now we're going to substitute it in. We leave density D because it's our unknown variable. Mass is 114, writing that out of order, divided by 10. So what does that equal to? You can do that one in your head, can't you? 11.4, right? And our unit here would be grams per milliliter. And then when you do math, I want you to put a box around it. Because, okay, I'm sure the good kids in Paulding County would never do this. But I used to teach in Cobb County with bad kids. And this was a way they would cheat. There would be a problem like this and they wouldn't know how to do it. But they'd go, hey, there's only 2 answers. So what they would do is they would do everything they could with those 2 answers. They would multiply them. They would divide 114 by 10, then divide 10 by 114, then add them 114 plus 10, then subtract them. 114 minus 10, 10 minus 114. And then when I marked it wrong, they go, but look, I did it here, but they would have just done it every way possible. You see how they cheated? So I made it where you have to decide on your final answer and put a box around it. No box, no final answer, no credit. Yeah, that probably never occurred to you, did it? Doing the problem every possible way. All right. Okay, so now we're going to learn one last thing here. How are we doing on time? We're doing all right. Okay, so there's a thing called moles. And you will notice I have cute little moles around the room. Have you noticed the cute little moles yet? See the little mole by the periodic table? There's a mole on that box, on the bottom of the box. There's moles back there on the hood peeking at you. Look at the pink one. Isn't that one cute? This one's one of my favorite ones. I'll show it to the camera. Ooh, isn't that one cute? Okay, so why are there moles in the chemistry classroom? This is why. Let's make that get big again. Okay, so it is a unit of measurement in chemistry, specifically for chemistry. And you are familiar with units of measurements that have names. For example, if you go to the store to buy eggs, what unit do you buy them in?
Dozen.
A dozen, right? So dozen. And how many is a dozen? 12. So 12 has another name called dozen, correct? If you go buy socks, what unit do you buy them in?
Pair.
A pair. You buy them in a pair. And if it's people, you don't usually call them a pair, you call them a what? A couple. So there's another word. And how many is that? 2. So pair and couple, this has 3 names. If I say a couple, you know that's 2. If I say pair, you know it's 2. Or if I give you that, if I say 2, you know it's 2. It's a unit that has 3 names. So yes, 2 is also called a couple. I got that too. Okay, so how you get chemicals? I don't go get chemicals out of the stock room in cups or teaspoons. I don't get them in dozens. I get them in a unit called moles. Okay, and it has 3 names, just like the number 2. It is called the mole. It is also called Avogadro's number, because Amadeo Avogadro, and that remarkably looks like him. If you see a picture of him, my son Josh did a great job drawing his picture. That's what he looked like. A little crazy, doesn't he? With unusually big eyes. But anyway, he was all modest. He could have called it Avogadro's number when he invented it, but instead he called it the mole. Don't know why. But we want to honor him so much, we call it Avogadro's number anyway. So sometimes it's called the mole, sometimes it's called Avogadro's number, and what it's equal to is 6.02 times 10 to the 23rd. And this is a number you need to know from this point out of your science career. So I have a video on my YouTube channel about how to store it in your TI-84 calculator so you've always got it. Or I can show you all that later, but I don't want to take the time today. But you need to make sure you know this number. So, Sally, one of the things you missed was scientific notation. So be sure to go back and watch that video, or else that is crucial information you're going to need. Okay, so what is this number? Why is it so important? A mole of a chemical is the mass in grams, which is it's called molar mass, and I abbreviate it M&M. And do you see the M&Ms? Have you noticed the M&Ms on the periodic table? It's because you look at the periodic table to get the molar mass, which is the mass of 1 mole of that chemical in grams. I know that was a lot to take in, but as we do the math, this is going to make more sense. Okay? So we're going to do a little math so it makes more sense. So if we wanted to know the molar mass of nitrogen, come on, there we go. We would look on the periodic table. I've got one right here. Let's see if this will work. Yep. And you'll see on the periodic table this decimal number, 14.0067. On this periodic table, it's right here. 14.0067. So the mass of 1 mole of nitrogen is, you guessed it, 14. No, come on, draw for me. I have to do it over here. Sorry, board problems. We'll go back to blue. All right, should write now. 14. I want to do it. It doesn't have the thing. My new system was working so well. Let's try it right here. 14.0067. 67. All right, so what about lithium? What would be the molar mass of lithium? Do you see lithium?
6.941.
Yes, everybody sees where to get it on the periodic table. 6.941. What about oxygen? Can you read that one?
15.99.
15.9994. Now, in college, a lot of times they will make you use 15.9994. I'll let you round it to 16. Okay, so it's a little bit easier. Now, what about hydrogen? What's the molar mass of hydrogen?
1.00795.
Yes, 1.00795. Now, how about water? Is water on the periodic table? No. What is the formula for water? H2O. So we would add them up. Oxygen is 16. How many hydrogens do we have in a water? H what? 2O. So we have 2 of them. So 16, 17, 18. So if I wanted 1 mole of water, I would weigh out 18 grams. And that would be that many atoms, that many molecules of water. 6.02 times 10 to the 23rd. Now, is it exactly that number of molecules? No, but close enough. Does that make sense a little bit? Okay. All right, so how do you do these mole problems? Write what you know, write the units of what you know in the denominator, think of a conversion factor, do the math. Okay, so let's do an example problem of this. How many grams are 4 moles of carbon? Let's see if it'll let me write now. Nope. I think the problem is it keeps getting bigger and smaller. Oh, starting to write. Okay. So I start with what I know, 4 grams of carbon. I draw my train tracks. I push what I know to the denominator. Grams of carbon. I write what I want, moles of carbon, in the numerator. And what is the relationship? How many grams is 1 mole of carbon? Look on the periodic table. What is it? What's that little red number?
12.
12. So now I can do the math. 4 divided by 12 is what? You can do it on your calculator if you need to.
3.
Not 3.
Oh, wait.
It could be the other way. 12 divided by 4 is 3, so do it on your calculator. And I want y'all, some of y'all like doing math in your head. What is it?
0.3 repeated.
0.3 repeated. And how many should we round to? How many does that have? 1, so I should say 0.3 moles. Oh, you know, I did this all backwards. Did y'all notice? How many grams are 4 moles? I wrote my known down wrong. I'm like, yeah, this just doesn't seem like I give them one this hard. No. All right, so let's try it again. So this is 4, let's try it again, moles. So this is 1 mole, and this is 12 grams. How many grams? The question mark goes with grams, are 4 moles. I wrote 4 grams. 4 moles of carbon. Now, what is 4 times 12? This one's easier. 48. Do y'all know the song? It started with a 0. 12, 24, 36, 48, 60, 72, 84. Okay, we just had to sing the whole thing. We couldn't stop right there. 48 grams. Carbon. Yay, we did it right. Woo! That was difficult. Okay, so this is just the standard now. So that is all of Unit 1 test. Now, let me tell you in advance. Often the failure rate for Unit 1 test is about 50% because it's a math test. And some of y'all don't love math the way you should. So don't be one of that 50% that fails it. And how do you not fail it? We're going to do worksheets. You're going to do a problem, check your answer. Do a problem, check your answer. I promise you, if you can do all the problems on the homework, you can make an A on the test. But if you don't do your homework or you just copy the answers, you're probably going to be part of that 50%. And I'm okay with half of y'all failing the first test. I think it's just part of the learning process of how to learn chemistry. I know you might not be okay with it, but I'm fine with it. Because I know that just like when you started learning to ride a bike, you fell off the first time. Some of y'all are going to fall off, but that doesn't mean you're not going to learn how to ride. Okay? So I'm all right if you fall off the first one, but let's try not to, okay? All right, so I'm going to end the video here. Like, share, subscribe. Okay, I want to say smash that like button. All right, see you later. Science is great.